Just imagine what the ultimate time machine may look like. We used to think in times of cogs and flying wheels, a kind of industrial insect that would spin and flutter through time. But a modern vehicle that carries us away from the present might simply look like this: a room and a chair where the traveler could sit in comfort and decide the day, the hour, and the minute they wish to visit. Streaking through the ages, they would plunge into a world that once was, flipping through the centuries as one might flip through the pages of a history book. To achieve the dream of traveling back through time, we're going to need to develop some powerful technologies. But super-fast starships will never be enough. Science has warned us that even the fastest spacecraft still couldn't cross the light barrier. That's because when we gain speed, we gain mass. More mass means an increase in the force of the gravity. At the speed of light, 186,000 miles a second, we'd be crushed by gravitational forces before we could ever make it through the light barrier. But one loophole scientists have identified may provide a way around that problem. They're called wormholes. Wormholes are natural pathways that bypass space and time by jumping through them. Long journeys would become split-second hops. The wormholes eliminating the distance and time separating our departure and arrival points.
Go in one end, you come out the other. To an outside observer, it looks like you went faster than the speed of light. You're not torn apart by horrendous gravity fields. It doesn't take forever for you to travel through the wormhole.
These are the concepts behind Star Trek's Deep Space Nine. Starships zap through wormholes from one part of the universe to another, all without harming anyone on board with the deadly gravitational stresses of faster-than-light travel. We already know that wormholes exist in the so-called foam of the subatomic world. But their openings are billions and billions times smaller than the width of an atom. Even so, turning microscopic wormholes into highways to the past is theoretically possible.
The laws of physics, as best we know them, don't forbid us from traveling back into the past. And when the laws of physics don't forbid something, and we want to do it, then we usually end up doing it.
Could it be that one day starships like this will be driven from fantasy to reality by technologies that allow us to generate controllable wormholes? To cheat both space and time.
Now, it may be an engineering monstrosity to come up with fields and matter and energies that actually make it happen, but they're theoretically possible. Someone, somewhere, someday may make it happen.
Our challenge now, to boldly go where no scientist has gone before. To find ways to make such concepts a reality. Imagine how time travel would change our lives. In theory, we could jump into tomorrow and take a cruise through the streets of Las Vegas. Then turn back the clock and return to today with an inside knowledge that could win every gambling game in town. Just imagine knowing at what Hitler was going to do and having the ability to warn the world or even remove the Führer before he got into power. Tempting as it may seem to play hero in the past, there is a catch. It's called the grandfather paradox. A riddle so perplexing that some scientists believe it proves we'll never be able to travel into the past. If a time traveler were to go back in time and kill his grandfather before the grandfather had children, wouldn't that mean he would never have been born and therefore couldn't have traveled back in time to pull the trigger in the first place. If the problem sounds mind-boggling, then one possible solution may seem even more bizarre.
If you were to travel back in time and change something, you would necessarily end up in another universe, a parallel universe. And there'd be no way of getting back to the universe you started in. You'd be trapped.
Oxford University physicist David Deutsch believes that's nature's way of making sure time travelers can't interfere with what's already occurred in history, however ugly that may be. He calls it the multi-universe theory. It offers another loophole, a solution to the grandfather paradox. Deutsch believes there can be unlimited replicas of the world as we know it, all of them with potentially different historical outcomes. According to the theory, when we travel back in time, we enter another universe. That universe looks the same as ours, but it follows a different route through history simply because we've entered it and therefore changed it.
For instance, you could go back in time and meet another copy of yourself, a copy who didn't travel in time. And then the two of you would be there in the universe that you'd arrived in, but you'd be missing from the universe that you left.
In other words, in some universes, there could be a number of copies of the same person, while in others there'd be no evidence that that person had ever existed at all. Could that mean there are time travelers here now in our world? Visitors from the future who'd been trapped in their travels through history? Some scientists believe such visits may have been crucial to our very existence.
In fact, the very origin of life on this planet may have happened because of time travelers from our future who seeded the early Earth with the DNA molecules and the other molecules needed to form life.
If that's true, if anyone or anything has manipulated history by traveling back from the future or leaping into our universe from another, scientists can only speculate how their time machines may have worked. Did they use the wormholes we're looking for? Or have they mastered another way to beat the speed of light? Professor Gunter Nimms has stunned the world of physics. In his laboratory at the University of Cologne in Germany, he has broken the ultimate speed limit, the speed of light, the first hurdle in the race to travel through time. Professor Nimms achieved it thanks to a curious phenomenon known as quantum tunneling. It's another loophole in the laws which govern the universe, one which allows particles of light to somehow sidestep the barriers of time and space. Nimms's triumph lies in getting those light particles to carry information. He encodes music onto a laser beam and points it at the barrier. When the light particles or photons arrive at the other side, the music they carry can still be decoded and played. Nimms claims he has sent music in this way at almost 5 times the speed of light.
We were extremely embarrassed when we saw this on a Sunday morning, that our signals are moving faster than the velocity of light, and we went to some colleagues, to 2 colleagues from the theoretical department, and showed it to them, and they were also excited by this result.
The question now is how far can